Hello, good day viewers, you're welcome to Chemistry Hangout. If you are new to this channel, I want you to click the subscribe button because we have a lot of things in stock for us. For people that are used to this channel, I want to welcome us chemically. Well done. And for the students that are preparing for exam, I wish you the very best, and that is the reason why we are here. We are going to dissect the 2023 Chemistry Waec practical. That's the qualitative analysis. We are going to dissect everything here today, and you will see how simple these things are. The reason why we are doing all this is to make sure that we pass excellently and to tell us that we can actually do all these exams ourselves. Very, very important. So please watch this particular video to the end, share it. You can ask questions via the comment box section, but I want you to pay maximum attention because the test for this year is very interesting. For me personally, as a chemistry teacher, it is very, very interesting. And it tells us, it reminds us of some texts we should do as chemistry teachers. They are interesting, very, very interesting practical, very interesting test, and that's what we are going to be doing today. So I have for us, that's 2023 Waec practical qualitative analysis, and I've told you this is a prediction, but I am sure that if you follow my instructions, if you adhere strictly to my instructions, then you are going to meet 80% of this thing I am doing now. So pay attention, watch the video over and over and over again. Okay, meditate on it, ruminate on it, and I bet you that you are going to do excellently well in the exam. So very quickly, if you look at this, the predicted question, I said C is an inorganic compound. D is one of the following substances: starch or sucrose or glucose. So in your various center, they would have labeled, let's say they label this to be, let's say this is my D, they label this to be D, okay, they label this to be my C. Very, very important. The test is that you don't know all these things. Don't assume that you know it. It is the test that will confirm the validity or that will confirm the compound that we are testing for. So and that's the reason why I'm doing this practically. I am doing it practically for us to see it and for us to see that we don't really have any difficulty in all these things, just our understanding and how much we can do there in exam. I'm telling you, watch this very, very well. Meditate on it, study it very well. This will cover 80% of what you'll be meeting on that day as far as qualitative analysis is concerned. So here, they must have given you all this in your center. Label this specimen C, specimen D. This is my potassium dichromate. This is my saline solution A and B. Okay, this is water. This is my dilute HCl. This is sodium hydroxide. This is ammonia. All those things should be given to you in your center. So let's see the question. C is an inorganic compound. D is one of the following substances: starch or sucrose or glucose. Carry out the following exercises on C and D. Record the observations and the conclusion drawn from the result of each test. And you know why I love qualitative analysis? These things are things we are going to see. Okay, you are going to see these things yourself, and you will be recording what you have seen. And from your basic chemistry classes, when you see something, when you observe something as chemistry student or science student, you must be able to infer. If you see this, okay, what is this very particular thing I saw? What is it trying to say? And that's what covers this aspect, qualitative analysis. So C is an inorganic compound. So let me say this is my C. Okay, let me take my spatula. C is an inorganic compound. So let's see the test for C. Dissolve part of C in about 5 centimeter cube of tasty water. So I'll take around this. Let me take my test tube, okay? Okay, you can see that this is it. Let me write this first so that we'll just record immediately. Test, observation, okay, and inference. What am I inferring from those things? Test, observation, and inference. So please, the numbering is very important. You have to be orderly, please. The numbering. So we are working on A, Roman figure 1. So I will write A, Roman figure 1. Okay, so they said dissolve part of C, that's sample C now, in about 5 centimeter cube of distilled water. So let's say sample C plus 5 centimeter cube of distilled water. Okay, so that's the first thing we are doing. Sample C. So this is my water. So I can just use my discretion to to add the water, about 5 centimeter cube. Okay, let me say this 5 centimeter cube. So let's shake thoroughly. Very important. This is all part of saying about 5 centimeter and shake. Now the reason why they are asking you to shake it is for us to actually be sure of the solubility. Very, very important. Yes, we want to be sure of the solubility. And if you agree with me, when you shake it like this, okay, that's the reason why when you are doing qualitative analysis, when you shake like this, it will be as if everything has dissolved. But for you to be sure, you can just leave it to settle for a few minutes. If it has dissolved completely, then you will not be seeing any suspension or you will not be seeing the salt looking like it is insoluble in water. So we can just leave it. But from indications, let's just leave this a bit, okay, so that we'll be sure. I want us to be sure of the solubility. But before that, you can see like it's forming 2 layers. If you look at this, it's just like it has settled down. Can you see? Can you see? The salt has settled down and the water now is up. Can you see that now? So very, very important. So what is my inference? You can see that. Okay, so my observation is what? White suspension observed or formed. White suspension observed or formed. Why is this white suspension? You can see it. It's very obvious. Can you see? Why is the white suspension formed? What's the meaning of that? If I say something like this, it means that my sample C, let me say C is insoluble. It's insoluble in what? In water. You can see that. So my inference is from my observation that, okay, my C is insoluble. Look at that. You can see. Look at it. It's insoluble. So white suspension formed, the white suspension observed. Okay, it means that C is insoluble in water. What's the next thing? Test with litmus paper. So plus litmus paper. So what is the action on litmus paper? Definitely I will be testing with my red and blue, because I don't know if it is acidic, if it is basic. So I cannot use only red, okay? So I'll be using red, I'll be using blue. So let's see. The red, let's see. Okay? No effect, it's not changing. It's not changing my red. Can you see that? So let me see my blue. Let's see my blue. Let's see my blue. You can see, it's not changing my blue too. So what's the meaning of that? Plus litmus paper, what's the meaning? No effect, right? On litmus paper. So what is my inference? If it's not having, that means not basic, it's not acidic. So I can say solution C is neutral. I hope this is clear. And that's the interesting aspect of qualitative analysis. You can see, we are just recording what we saw. Okay? We are recording what we saw. So it's not science is so interesting when it comes to practical. So interesting. I love the practical aspect. Because you cannot tell me that it is acidic. You cannot tell me it is basic, because I've tested with blue litmus paper, I've tested with red, and there is no effect. So that is sorted. Let's divide the solution into 2 parts. So I'm dividing this solution now into 2 parts. Let me shake. So let me divide into the first part. Okay? So let me leave this. So this is the first portion now. Let me say this is the first portion. So to the first portion, that's the first portion. Add sodium hydroxide in drop and in excess. So the numbering, very important, I've told you. So this is Roman figure 2 now. Here, Roman figure 2. So we have first portion of what? Of CRB plus sodium hydroxide. Please, if you write only this, it means you are talking about the sodium hydroxide pellet, and you are not giving the pellet. What are you giving? Let me look at it. The solution, you are giving the liquid. So very important. I need to put my AQ. That's AQ. So let's add in drop and in excess. In drop and in excess. Let's see. Don't forget this is insoluble before. So let's see. In water. Let's see. In drop and in excess. Chemistry is interesting. Can you see what is happening now? Dissolving. You can see it. You can see. So you can see it dissolved. Immediately I added ammonia and sodium hydroxide. It dissolved that very particular solution. So what is my inference? And a white precipitate. Am I right? Yes. White precipitate. So I can say white precipitate, right? Soluble in excess sodium hydroxide. Okay, from your basic chemistry knowledge, if it is white precipitate, what's the inference? The inference will now be either lead, okay, either aluminium or zinc is what is present. Can you see that? Very nice. Very simple test. Very simple test. To the second portion, to the first portion we have done that. To the second portion of D, is it D? This, so it should be C, not D. That should be listed. To the second portion of C, so this will now be C. Okay, so these ones are D because that will be the next test for this. So it is to be D. So that will be D about. Yeah, thoroughly and stay with it. Okay, so that's test for the second one. So, okay, so to the second portion of C, and they ask us to divide into 2. So let me take this again. I have enough test tube here. Let me shake. Okay. Then I will add excess ammonia. Portion of C. Can you see? Add ammonia in excess. So ammonia in excess, ammonia. Okay, I added ammonia, sorry. That's, let me see. To the second portion, to the first portion, sorry, add sodium hydroxide. Let's do that again. Sorry, I should be adding sodium hydroxide first. So let's see. Okay, same test. You can see that. Same test. You can see, very, very soluble. So I am right. Okay, I even wrote sodium hydroxide and now added, so this is correct. This is correct then. So this sodium hydroxide added, soluble, then definitely white precipitate, definitely soluble in excess, we can see. Then this, correct. That's correct. So ammonia is now the confirmation. So let me have another portion, Abi. Another portion, let me use another test too. So we use ammonia to now confirm the test. Use ammonia. It's a very simple test. Very, very simple test. So I'm using ammonia now. I use sodium hydroxide first. I'm using ammonia now. Can you see that? Very soluble. Wow. Very, very soluble. Can you see? Very soluble. Meaning, first portion plus what? Plus sodium hydroxide. Abi? So now I have to the second portion now. So I have Roman figure, what is that? 3. Okay? Roman figure 3. Second portion of C plus ammonia. Okay. You can see that. So I want to, you can just say my white gelatinous, like a gel. That's the meaning. Like a gel. So now precipitate. Also soluble. Soluble in what? In excess ammonia. And from your basic rudiments of chemistry, immediately there is a white precipitate in sodium hydroxide that is soluble. There is a white precipitate again in excess ammonia that is soluble. It means that your zinc 2-ion is what? It's confirmed. That's a confirmatory test. One of the confirmatory tests for zinc. Yeah, that's one of the confirmatory tests for zinc. So the now said put the rest of C in a test tube and eat strongly. So we are done with this. Very important. And that's the reason why I said it's simple. It's what you are seeing, you'll be recording. So put the rest of C in a test tube. So let me put it in because I want to eat it anyway. So let me put it in an evaporating dish. Okay? Let me put it in an evaporating dish because I need to eat it strongly. So let me put in an evaporating dish. So let's say this is the remaining. Please, what's the color? Let's see the color before we put it there. White, right? This white. Okay, so let's put little. Okay. So we can see that now. White. So let me eat strongly while we continue with other tests. So let's just say, what's the numbering for? So let's just say sample, okay? Sample C plus what? Plus eat, right? So eat it strongly. White in color before eating. Sorry? Okay. Let me. Okay, so let's leave this. Let me reduce a bit. Okay, so let's leave that. So we are going to record that later after some minutes. We are going to record that after some minutes. So then the next one now. Let's move to the next one very quickly. So for that we just leave it. Let's have a confirmation. Then they said add about 5 cm cube of distilled water to portion D in a test tube. Stir thoroughly and test with litmus. So let me use another. Let me use this. Okay. Let me use this. So this is the specimen given. Put little. So where's my water? This is my water. So let's shake. What did they ask us to do? They said stir. Okay, let me stir with my glass rod. Let me stir with my glass rod. You can see, very soluble. You can see that. So these things are things we are seeing. You can see it. So we come to B now, right? We are still leaving this for the action of it. So B now, add of distilled water portion in the test to stir thoroughly. So this B. So that means sample what? D now. Sample D plus distilled water. Okay, can you see it? Very soluble. So I can say D dissolves completely in distilled water to form a colorless solution. Can you see that? So what is that mean? If it dissolves completely, then I can say D is soluble, right? So since it dissolves completely, then D is soluble in water, then I can have my inference like that. I want to believe you are following. Okay, so the next one. What's the next one? They said stir thoroughly and test with litmus paper. Wow. So they want us to test with litmus paper again. Let's test with blue. Let's test with blue. You can see. No effect. Let's test with red. You can see. No effect. So even from the one I did, you should understand. So what we did today now, plus litmus paper. So you should know the observation now. So what's the observation? Okay, let me use my duster so that it will be clear. I want us to get this once and for all. Use my duster now. So let me say test, observation, and what? An inference. I want to believe you are enjoying this. So these are simple tests. And I tell you, this will cover 80% of what you are going to be seeing in the exam. So let me start from here. Okay, plus, that's B, right? B So plus litmus paper. So we saw it that no effect, right, on litmus paper. Okay, if you are following me, then you should know what the inference is going to be. So what is the inference? Solution D, right, is what? Is neutral. Why is it neutral? It's not having effect on blue litmus paper. It's not having effect on what? On red litmus paper. So I can say solution D is neutral. Okay, what's the next one? For the first portion, okay, divide into two parts again. So this is it. Okay, let me use, since it's two, I can have one here, then one in here. So I can have one here, then I'll use this other one. But don't let me finish it. Don't forget we are still eating a substance. Come and see it. Wow, wow, wow. You can see. You can see the color changing from white to yellow, but it's still coming up. It's still coming up. We are still coming back to that. We're coming back to that. So that we'll be sure. So we are still coming back to that. So, no effect on litmus paper. So this is the first portion, right? What did they ask us to have? K2CR2O7. This is it. K2CR2O7. Let me add it to, so that it will not be too much. Okay, I think that's fine. Look at the color of K2, like orange. You can see. That's the color of your K2CR2O7. So let's add about 2 centimeter cube. Let me just use my discretion. And keep. So let's keep it. Let me add little of this again. Okay. I want it to be obvious so that we see what the color is like. So let's see. Let's keep it. Okay. So and keep, so we can add this. What's the Roman figure? Roman figure 1. Okay, solution, first portion, right? First portion of solution D, okay? Plus K2CR2O7 aqueous. So let's see what is going to be. We are still keeping because they asked us to keep it. So let's keep for some minute too. Let's keep for some minute. Then what's the next one? For the second portion. So that will be Roman figure 2, B Roman figure 2. Second portion of D plus Feline's solution. Feline's solution A and B. So that's what. So this is my Feline's solution A and B. So I need to be careful with that because I want to add in right proportion. Yes, come and see this. Because I still want to eat here. Because they said eat gently. So we are still eating. So I want us to finalize this. Can you see it? Can you see that? That's the beauty of chemistry. So let me quickly record that. Now, sample C plus eat. Abi? Because, okay, let me use it. Change from white, right, to yellow. Okay? On what? On eating. Can you see that as we have seen there? So what is that? That's a confirmatory test. Zinc, let me say sample C is what? Zinc oxide. That's the only compound that will change from white to yellow when heated. And if you cool it again, it turns back to white. So change from white or turn from white to yellow on heating, then sample C is what? Is zinc oxide. Okay? So that is that for that. So from here, second portion, Ferlin solution. Where is my second portion? Is it this? Yeah, it should be this. Yeah, it should be this. Okay. I don't want to waste it so that we can, if I thought we need to do another one, so I don't want to waste, or let me just wash this with water from the previous one. So because I still want to have little of it. You can check again, you can check our zinc oxide for confirmation. Okay, so let me have little again here. Let me just have little. Okay, Ferlin solution A and B. So this is my Ferlin solution A and B. So I'm using 1 centimeter of them. So this Ferlin solution A, I'll measure just 1 centimeter. That's why I'm using my measuring cylinder here. 1 centimeter. This is it. Put it inside. Let me leave. Ferlin solution B. This B, this A. I've used A, this A, so I'm using B now. A. Let's add 1 centimeter. So it's Ferlin solution B. This Ferlin solution B. That's it. Okay, so to eat. Gently. I hope you are seeing it. You are seeing the color. You are seeing the change in color now. Can you see that now? Go. Okay, gently, careful. Go, go, go. Can you see it now? Can you see? This is a confirmatory test. It's now. You can see the color. Okay? Can you see the color now? So what's this color? What's this? Look at this. This is a brick red. This is a brick red. On eating, it shows positive test to Ferlin solution A and B. You can see this is a brick red. So I'll write second portion of Ferlin solution. So a brick red precipitate form. So and if a brick red precipitate is formed, then glucose is what? Is confirmed. I hope this is clear. So glucose is confirmed. Why? Because glucose has the functional group of the alkanal and it's a reducing sugar. So that's the reason why it's now giving a positive test to Ferlin solution A and B. Can you see it? On eating, it's changing to brick red, and that's all. So for this now, it means what? Your this very particular compound here is what? It's glucose because of the formation of a brick red. You can see a brick red. Some textbook will say a brownish red. Yeah, some people say brownish, but I love to put brick red is confirmed. Okay, so from there now, let's now look at this. You can see. Can you see this now? You can see changing what to yellow. The heat is so that is that now. You have done that test already. So let me off this. Okay, you can see this now. From you can see to yellow. So zinc oxide is confirmed. So our brick red confirmed too. Okay, let's see our. Can you see something? If I shake, look at the color. Look at the color that you are seeing. As if it's a light as if you are seeing a green color, on addition to our K2CR207, which is here. So first portion, so that will be orange. color of K2CR2O7 aqueous changes to a light green. Okay, so solution D is this. So what is this? It means that your solution D is a reducing agent, because your K2CR2O7 is an oxidizing agent. And don't forget that your glucose is a reducing sugar because of the alkyl functional group that you have there. So I can infer that what D, this very particular substance D, is a reducing agent, and that's the reason why you are seeing the color of K2CR2O changing from orange to green, which means it has reduced chromate 6 to 3. That's what it will be. So D is a reducing agent, and that's just the test. That's just it. So particularly, I love this test. For you can see the brick red. You can see I love this glucose test, and that's just what you're testing for. So you can see the test. Okay, you can see even this one now. We want it to change back to white on cooling. Yellow before, but you see, if you leave it for hours now, it's going to change back. And that's all. If you know this, I am telling you, this is 80% correct. I can assure you that. And we are doing this practically to help us grow in chemistry, So this is just it. This is what you'll be making. If you are new to this channel, don't forget to subscribe. As far as chemistry content is concerned, Chemistry Hangout will always want to give you the best. And for teachers that have been reaching out to me, the preparation of laboratory reagents, the course is still on. It's wonderfully packaged. You can check my previous video before I posted this, of comments of teachers that has actually had access to that video. And I tell you, if you are a teacher, you need to actually sharpen your practical skills. So you can DM me. If you check the previous video, there is a link there. If you click the link, it's going to actually take you to my DM, and I'll still put my number on the screen. You are seeing it now, okay, so that you can chat me up if you still need it. I wish my students, everybody, success all over the world, in Nigeria, in all parts of the state of Nigeria. I wish you guys good. Just go over this, and I tell you, you're going to come back with testimony. Till we meet again, this is Chemistry Hangout. I love you guys. Thank you.